I say to you before, we are on very concrete robots coming to the market, but I want also to introduce you to Yanne Coucoux, who's today the only girl in the team here, first thing. And second thing, she's also the only who's bringing us a robot direct on the booth. It's this one. And 3.3, it's the only robot we will see today in a breeding for cattle breeding, and especially for poultry. That's right, Yanne.
Thank you, Benoit. I wasn't sure whether I was going to pitch in English or in French, so I decided to take a middle way. So my slides are in English, and I'm going to speak in French. Sorry for the translator. This is not fully finished yet for you today. I'm very lucky indeed. I am the only one who can bring my robot on stage. I'm not gonna get it running, it can be a bit noisy and it's gonna bump everywhere. But just for you to take a quick look on the sounds and the lights. I will speak a little bit more about this after. Why do we have sounds and lights on the robots? Donc, je suis Yanne Coucoux, je suis la DG de Tibot.
Mrs. Coucoux. I am the general manager of Tibot, of the Inc. We are a pioneering company in terms of high-tech in the development of assistant robots for the poultry industry. We have visited a lot of fields, so we are now going to be in the midst of the poultry industry. That's true that a lot of work has been conducted on cattle, large cattle, but the poultry industry had been kind of discarded, ignored when it comes to when it comes to robot implementation. And robotics is meant to assist the breeder as much as possible when conducted cumbersome tasks. Our company has been designed to develop reliable, robust robots with a view to increase the farmers' profitability, to modernize their farm, to promote the animal welfare, and to upgrade the farmers' working conditions. I don't know if there are any poultry breeder around in this hall, but I'm going to describe this entrepreneurial. I'm going to explain how we have designed this Sputnik robot.
L'équipe de Tibot, c'est d'abord Benoît Savary.
So, who are we? Bruno Savary has been working in this sector for years and has been describing detailedly what floor laying was consisting in, and has explained what the problems were, what the situation was. So we used one of his sheds as kind of laboratory to conduct our tests. As far as I'm concerned, I'm in charge of the financial side of things, of ventures and connections with startups, and we have got a third colleague who has been working in car processes, in industrialized car processes for 15 years. That's why he knows a lot about robust and reliable systems. We also have a R&D team with Pierre, who is the technical project manager, Georges dealing with the onboard systems, David dealing with these systems, and Jean-Noël dealing with the user interface aspects. It's still a small company. That's why I'm introducing all the colleagues. What about our approach? We decided to work from and on the site, from the breeding or rearing shed, and we have got two basic working principles. We work for and with breeding poultry and laying poultry, of course, eggs that you can eat day after day. And we also work on what we call the broiler poultry, that is to say chicken, hens, etc. And when it comes to egg laying, the eggs that are laid on the floor are displaced, are moved around. They can be contaminated with bacteria, they can be dirty. That means that they are discarded or they are set aside, which means loss of revenue, loss of earnings for the farmers. So in order to address these problems, we have quite often hens laying eggs everywhere and not only in their nests. That means that if the hens lay their eggs all around the breeding space, you have to walk all over the place to collect the eggs. And when visiting the breeding farms, for the first time, poultry farm for the first time, you can smell a lot of ammonia. You have to walk around to collect 1,001 to 1,200 eggs a day. That means bending, etc., kneeling, and so on and so forth. That's not the same, of course, with broiler poultry, but the animals that are bred for such a goal do not move. They are around, they are rather static, so they may catch diseases, they get fat, they produce fat. And so we decided to have a robot acting the part of a sports coach, making the animals move around so that they produce less fat and better flesh. We have tested our system in the field. We conducted about 10 experiments. The aim was to get good results. I'm not talking here of scientific results, since we really studied what was going on at the farm. And when looking at the breeding poultry, we realized that it was possible to decrease this floor laying by 23% in 2 weeks with a robot. In other cases, it takes at least 6 weeks, and the use of the robot made it possible for the farmer to work 50% less. That means the farmer had just to go around the farm once per hour and not twice per hour. In terms of broiler poultry, we had heavier turkeys that had eaten less. That means that they ingest the food so much so that they produce less fat and more muscle with what they eat. We have also tried to validate our observations and our results on the market and by the market. The commercial launch took place mid-September, last September. It's faring quite well. The sale of robots has been on the increase lately. We already have 14 customers worldwide, a lot of foreign demand, high foreign demand. That means we have rightly targeted our the sector of activity. And that also means it's an international concern. We are raising funds, and the point is to raise sufficient funding to speed up our marketing and increase the number of international prospects. I mean, international markets are now a priority, and we also intend to design a new generation of robot, a new breeding of robot, I would say, that will have more functionalities. Thank you.
Je t'ai demandé de me donner un scoop pour écrire dans mes journaux.
I asked you for a scoop so that I can write an article in the papers, but I won't talk about this right away. We'll wait a bit. I'd like to give the floor to Cédric Bache, director of Vitibot, for robots which are specialized in viticulture. Indeed, I'm going to tell you about a special agricultural sector, the world of vineyards and winemaking. We have special characteristics in this field. My name is Cédric Bache, young CEO of Vitibot, a company which I created with my father, who is a vine grower, following a real demand that was identified by the agricultural sector through my father. Concerning the issues we have, the main one, as we are in the Champenois region, it is a very small market with its own specificities, but it is important to note that the main issue is safety, the safety of our operators. On slopey areas, treatments were done with helicopters because there is a real danger to go on a machine on these very slopey lands. This technique, in fact, was forbidden by the European Union at the end of 2016, and this poses great safety problems because the only alternative to treat vineyards except with helicopters, is with a crawler machine. The operator follows the vehicle, and when you spread products to treat the vineyard, you have to go behind the machine. Very often the treatments are carried out in the summer, in the sun, in the heat. The operators are usually not protected correctly because you are very hot under those clothes. There are risks of muscular and skeletal disorders. The machine weighs 500 kilos, and there is a danger of the machine falling on the person. We have lethal accidents every year, and with more traditional machines, we never exclude the risk of accidents, perhaps due to a human error. The second major challenge, and this is a traditional one, is the environmental issue. This is a map presented 2 years ago, which was talked about a lot. We have the region of Champagne there with a very bad color, negative color, and on our territory it is a great shock because our wine is a luxury wine, and when you deal with luxury products, you can't afford to be associated with these problems. There are new solutions now to reduce the use of chemicals. We're talking about glyphosate a lot at the moment. This is a potent herbicide. If you want to weed 1 hectare of vineyard with a herbicide, is going to take about an hour in the year. Very simply because we have machines and it's done very well and very quickly. The alternative is to have to do mechanical weeding. You can do that with a conventional machine, but there are 3 problems. First of all, you have to do it several times a year. You go a lot more slowly. You work on less rows at a time because you need more precision in such a way that you increase your work by a factor of 16. You need 16 hours of work in the year to do mechanical weeding, while you needed only 1 hour before. 16 hours, that means 16 more machines, 16 more staff with the additional costs. So the solution for us is to have a machine that is 100% autonomous and that can do all those time-consuming jobs, because we talked about the mechanical alternatives with more work with the machine, but the spray is limited. Today we spray the product from the top with sprayers, but in the future, we'll use systems which are being developed today. That is to say that we will close up a plot of vineyard. We will spray the whole plot. 80% of the product will be sprayed at the beginning of the season. If you have a branch with a few buds, for example, that you spray, you lose the product. So over the year, we recover 40% of the product. But it's very time-consuming. So if we want to use less products tomorrow, we need to find solutions to counteract this problem of using time-consuming techniques. Hence the solution of having a 100% autonomous robot. Electrical and autonomous machines, that goes in the right direction. Tomorrow we'll be able to fuel our machines with renewable energies. We encourage our farmers in that direction. Machines with solar panels, for example. Our machine here weighs 2.5 tons. We are going to work on slopey lands, so there are serious constraints to be taken into account, and therefore our machine still weighs a lot. We can improve human safety. There is more flexibility because between 2 showers, when you treat the vine, you need to take advantage, for example, of night time by using autonomous machines, which are very silent as well, which are very quiet. Precision and repeatability are also very important. In Champagne, this is an important issue. If after a long day, the farmer breaks a vine, for example, a vine costs between 2,000 and 3,000 euros in the end. So there is a lot of yield, which is very important here, because on that territory there is a lot of value added. Like what has been done and said today, our technology is slightly different. We integrate a lot of sensors on the machine. We pull together all the data. We have a machine which is really intelligent. When a human, like a human being, is going to perceive the environment and analyze it, understand it, and circulate, move around in the vineyard. You can see a vehicle in a vineyard, and on the right-hand side, you see what the machine sees in a plot. Thanks to that, we follow the rows. We turn round at the end of a row and we can work the whole plot. So there is a lot of artificial intelligence there. If we compare with what exists today, you can see a conventional machine there, tractor. At the top, you can see the comparison in terms of cost between the crawler tractor and the three-row hydraulic tractor. So what we have noticed is this autonomous tractor will divide in two the cost of work. It's very important because tomorrow is going to enable the vine growers to adopt these methods which are more ecological. Today they don't have the tools to do this, but we have to lower the cost the day of tomorrow if we want them to adopt these machines. These machines are more autonomous than electrical, but we can perhaps reduce the cost of all the other variables. The cost in fuel, for example, 10 liters of gas oil per hour is used. If we want to do mechanical weeding, we want to be more economical, but we use more fuel. Is it really more ecological? We can wonder. Hence, the idea to use electrical machines. Then there are problems of maintenance. Every 300 hours, the whole hydraulic circuit has got to be emptied. 1,500 euros is the cost. And then we have the operator, who is not blocked up on his machine and that can work somewhere else. Finally, the last point is compaction, soil compaction. With a conventional machine, we have 5 or 6 tons. We have half of this, but the soil compaction is divided by a factor of 4. We are lighter, but we have distributed the weight more easily between the rear and the front, because thermal vehicles have all the elements at the back, the fuel tank and etc. So the whole weight is at the back and compacted the soil more quickly. So if we'll have to have lighter machines in the future, and with a machine of 2.5 tons, we can improve things a great deal. I had a small video to show you. I don't know if we have it there. But we have a prototype which works very well, which we have used in the whole of the Champagne region. So this is our vision for tomorrow, to have machines that work, that are fueled with solar panels. So a virtuous machine for sustainable agriculture. I thank you very much.
Cédric, merci. And now somebody from Denmark coming to explain us, somebody from Agriintelli, Claes Dühring Jæger, who's in charge of the development from Agriintelli, and he will present us, if he's not injured, Robotic and autonomous transport solution. That's right?
Yes. Thank you very much. Yes, thank you for the presentation. I'm from the Danish company Agriintelli, and we are fairly new and compared to a lot of other companies, pretty small. Today I'll tell you a bit about our company. I'll introduce our robotic platform that we call the Robotic, the farmer's view on the platform, and a little bit about what we can use it for. I'm the Chief Development Engineer of the company. I'm Danish, and I have a master's degree in electrical engineering. Our company has the vision to use a lot of technical knowledge and scientific results and actually take these results and put into products. The main way we use that is being partners in research projects, and currently we are participating in 11 publicly funded research projects, either funded from Denmark or via the Horizon 2020 program. So what we want to do is create revolutionary and radical products or innovations, and basically want to annoy the big companies with our products and hopefully be better. One of our main project groups is our robotic project groups, and that consists of our Robotic. It's a modular platform. It's easy to customize. It's easy to change the working with. It's very simple to operate, and it's multifunctional. We have built it with an integrated safety system. So that means we should now be compliant with the European legislation. So it should be legal to let this robot run in the normal arable fields. A little bit about the history of the robot. The first version was presented in 2013 at Kongskilde. It was a complete electrical version working with the tracks, but then we learned the tracks in the headland when it turns functions more as a weeder. So we had to drop that idea and we moved over to wheels instead. So in 2015 we presented the second generation. This was still a completely electronical platform. From 2015 to 2017 we upgraded the platform. It's still completely electrical, but we also made a decision to move from electricity to a diesel hydraulic powered robot. So the third generation that we presented at Agriintelli, a Danish agricultural trade fair, is the propulsion is hydraulic and is powered by a diesel engine. And we are now at the fourth generation. So as I said, the working width is modular, so it can be ordered either with 1 or between 1 and 3 meters of working width. We copied a bit from the tractor manufacturers, so it's equipped with a category 2 or 2N 3-point hitch that you also find on a lot of tractors. And there's an option for a PTO and also hydraulic plugs. So if your implements are powered by a PTO or hydraulics, we can also power those implements. It's a low weight compared to a tractor, but not if we compare it to some of the other robots. It weighs at the moment around 800 kilos without implements. Our operating speed is around 6 kilometers per hour, because so far we haven't seen any proof that the quality of the work the implements do increases with speed. So actually the lower you drive, or the slower you drive, normally the higher the quality of the work. We changed from generation 2 to generation 3 and 4 to be a 4-wheel drive, and again to having a diesel hydraulic propulsion. So the retail price that we have for the standard version is at the moment 72,000 euros. So it's not cheap, but it's a lot cheaper than a tractor. If you want it equipped with PTO and hydraulics, the price increases a bit. The status of the robot is that right now we are finishing the testing of the prototype, and in 2018 we will release a limited O series. So in May or June we will have the first 8 robots ready, and we already made agreements with farmers who will test them, and in around October we should have the last 12 robots finished. So hopefully in the end of next year we have around 20 robots working in Denmark. When we presented the robot in Agriintelli, we got 3 new stars, and we also were awarded with the Agriintelli Award, meaning it's a pioneering new innovation. And when we look at the robot, it's not that different from what was presented already in 2011, but the main reasons for getting this price was that it was diesel-driven, it had hydraulic propulsion, and it had the standard 3-point hitch. None of the other robots that we have seen so far match this. Greenbot from the Netherlands comes close, but they are more autonomous tractor than actually what I would call a robot. It was farmers awarding or giving out this award, deciding who should receive it. And farmers, they really like diesel, and they really like diesel engines. As Simon Blackmore said earlier, he also likes the sound and the smell of the diesel. And then they also like hydraulics because they know hydraulics, and they have the idea if something goes wrong, they can actually fix the robot. They can't because they don't understand the system, but it's familiar to them. The feedback we got from the first robot that was completely electric was that they didn't want to work with it. They couldn't see how they should change the batteries or how to maintain it. And that's one of the main reasons we also changed from electric version to the diesel hydraulic. And apparently the farmers really like it. So this is the latest photos we have. Also, one of the main differences from us is that we would like to use standard existing implements. So this is a normal seeder that you can buy, that you can fit on your tractor. You can also fit it onto our robot and use your standard working widths. So we also want the robot to have a multi-purpose. So not just buy one robot only for weeding or one robot for seeding. We would like to have our robot being able to do all the operations. It's not powerful enough to plow, but it can do a lot of the other operations. And we can also have more robots running next to each other to actually reduce the downtime. Because today, if a tractor breaks down, then the entire operation stops. But if you have 3 robots running next to each other, and one robot breaks down, the 2 others can still continue and actually finish the operation. So here we show it with another seeder, and we actually designed the size, so it's possible, and size and weight, so it's possible to move the robot with a car or a tractor on a normal trailer. And also get it to the field with the trailer. So it's a bit shorter than the other presentations, but that's it.
Claes, thank you. You just presented us a multi-purpose platform, I say it at the beginning, and now we've got